And this chapter 3, we are going to summarize the chapter 3, network protocols and communications. Uh, okay, okay, recording. Let's start. Communication fundamentals. Let's watch this. Okay, so in communication, human communication and um, computer communication is somehow they are the same. Why? Wait. Why? It's because in human communication you need two people, two person to create a communication. And in a computer communication, you also need a two two computers to create a communication. And in communication, the other person will going to create a message and send the message through a medium to the other people, to the other person, and the people will receive and give a feedback. And also a computer communication as like that. Then let's proceed. Role establishment. An identified sender, receiver should always account for the following requirements. Common language and grammar should be the same. Speed and timing of delivery. Confirmation of acknowledgement. Two, message encoding. The message will be encoded first, and the message formatting and encapsulation, the message size, message timing, and message delivery options. Next, um, next is message encoding. What is in here on message encoding? Let's watch the figure. Okay, then so and this encode and message encoding, the receiver will encode the message from the sender. Like decoded, the source encoded. It's like the person will going to visualize a something like this, a sunset, and he will she will encode it, then send to this person, send his friend. If it's sent, the his friend will going to decode it and analyze what the information that she sent. So she visualized a sunset. So if she said, so he will going to decode it and he will also visualize the sunset. Now on this computer, this computer will send a picture of sunset. So the computer will encode it. Then the destination computer will decode it and it will display a sunset also. Message formatting and encapsulation. Okay, let's play. Okay, the envelope is the addressing. It's like the MAC address and IP addresses. And the encapsulated letter is the data. So it will be encapsulated to the envelope and it will be sent to its destination. Okay, then, so, okay, this is yung kanina, the frame addressing and encapsulated message. So, on letter writing is one of the most common forms of written human communication. For centuries, the agreed format for personal letters has not changed in many cultures. A personal letter contains the following: an identifier of the recipient, yung salutations or greeting, the name content, the closing phrase, and the identifier of the sender. This is the name where the message will be sent, and the salutations are greeting like dear Jane, and the message content. What does the letter content, and the closing phrase, and an identifier of whom I sent. Example: I sent a message so from Edward. Like that. Okay, done. The message size. Message is another role of communication is size. Okay, let's take. Okay, she visualized something and said a lot of things. Okay, and next video. Okay, the size matters on sending a message. Why? Because if you if you are so fast in talking and you talk a lot, it may cause some misunderstanding with with someone you're talking to. Like for example, me, uh, I said a lot of things then on a single time, and it's so fast, and there are so many words that I've said. Maybe the my my friend that I'm talking to, he or she couldn't analyze what I've said. Like the computer, like a computer, if you send very big on ng isang bagsakan, maybe the computer will not able to understand it. Next. Message timing. Okay, start again. Okay, the message timing is it's better if the one of them is communicating one by one. For example, the woman will go to talk first. Then after she talk, that's the time that this man will go answer. Okay, access method. Access method determines when someone is able to send a message. Message timing needs access method to know when someone is able to send message. And flow control. Timing also affects how much information. So if you both pagsabay kayong nagsalita, then there's a lot of words on on for example on the phone you're talking to your friend and there's a lot of words and you talk sabay kayo nag-uusap, there's a big possibility that you will not understand each other. And response timeout: if a person asks question and does not hear a response within an acceptable time, the person assumes that no answer is coming and reacts accordingly. The person, okay, response timeout. Message delivery options. Message delivery options. It may be unicast, multicast, or broadcast. If it is a unicast, you're possibly you are talking to one person only, and multicast to a group of people, and a broadcast is to a lot of people. Also, a computer, if the source send a unicast message, it will go directly to its destination. If multicast, it will go to a group group of hosts that has a same destination. If broadcast, it will go through all of the hosts on the network. Unicast is one is to one, and multicast is one is to many. Also, the broadcast. Okay, let's proceed. Rules that govern communication. Protocol suite, content layer, where's the cafe, conversion protocol suite, use a common language, wait your turn, signal when finished. Okay, physical layer. Then proceed. Network protocols. Hmm. The roles of protocols is the formal structure of communication process. I will send message across the network using an IPv4 header. Okay. At human level, some communication rules are formal and others simply understood based on IP in this course refer to both IPv4 and IPv6. IPv6 the most okay. Fig- the figure illustrated networking protocols describe the following process: how the message is formatted, the process. Figure 2, how the process switch working device. Okay, not too important. Protocols. It's protocols interaction is depends on the layer. Communication between a web server and web client is an example of interaction between several protocols. The protocol shown figure is HTTP, the application protocol that governs the way a web server and a web client interact. Okay, it's HTTP, Hypertext Transfer Protocol. Next is on Transport Protocol, TCP, this transmission control protocol, the transport protocol that manage individual conversation. Okay, it divides the HTTP message into smaller pieces called segment, and IP is responsible for taking formatted segments from TCP and encapsulating them into packets. Then an Ethernet um, is a network access protocol that describes primary function communication over data link and the physical transmission of data and network media. Next, protocol suite and industry standards. Uh, we have three TCP IP layer: application transport, internet, and network access. And let's proceed next. Next, okay, the TCP IP protocol suite. The application layer contains uh, name system, host config, email, file transfer, and web. Web is always HTTP, set rules of exchanging text, graphic images, etc. on the World Wide Web. File transfer is set rules enable user to host access to transfer file over a network. TFTP, a simple connectionless file transfer protocol. It is also a best effort. What by means of best effort in these chapters, it is an unreliable and it's unacknowledged file delivery plus overhead at TP. SMTP is simple mail transfer protocol, enables clients to send email to mail server, and enables server to send email to other server. POP, enable Post Office Protocol version 3, IMAP, Internet Message Access Protocol, Bootstrap Protocol, Dynamic Host Configuration Protocol, and DNS, Domain Name System Protocol. UDP, User Datagram Protocol, TCP, Transmission Control Protocol. Later on other chapter, we will discuss UDP and TCP, Internet Layer, IP, Internet Protocol, NAT, Network Address Translation, ICMP, Internet Control Message Protocol, OSPF, Open Short Pass First, EIGRF, P rather, Enhanced Interior Gateway Routing Protocol, ARP Address Resolution Protocol, TCP Point-to-Point Protocol, Ethernet, and Interface Drivers. Next. Encapsulation is the data. This is the user data. This is the user data. It will be encapsulated. The next is TCP. It will be become segment. Then after it becomes segment, it will be encapsulated to IP packet. It will now become a packet. and encapsulated in an Ethernet frame, then become a bit that will travel through media through the destination network, to the destination address. And on receiving the message, the bits will transferred, it will be decapsulated one by one. What I mean by one by one is the Ethernet will become a packet, and packet will become segment, and segment will become data that will display on the monitor of the computer. Mm, Open standards. Internet Society or ISOC, responsible for promoting all the open development and evolution of internet use. EALB or Internet Architecture Board, responsible for overall management and development of internet standard. IETF, Internet Engineering Task Force, develops, updates, maintains internet and TCP technologies. IRTF, Internet Research Task Force focuses on long-term research related to Internet and TCP/IP protocols. And standards on Figure 2 is Internet ICANN or Internet Corporation assign names and numbers based in the United States, coordinates, IP address, allocation management, domain names. And next is Internet Assigned Numbers Authority or IANA, responsible for overseeing and managing IP address allocation, domain name management, and protocol identifiers for ICANN. Next, next is Kupo naman ma. Ano ba? Oo, may hintay lang kasi sabi ko naman sa inyo pagka hindi ako nagbubukas, tatlong kato ko lang. Kupo, uulit na. And this one, the benefits of using a layered model. Benefits of using a layered model. Benefits of using a layered model to describe network protocols and operation include assessing protocol design because protocols that operate specific layer have defined information that they act upon and a defined interface to the layers above below. So a networking model is only a representation of a network operation. The model is not an actual network. Okay, there's a uh, two types of model: the TCP/IP model and the OSI model. The TCP/IP model is the protocol model, and the because TCP/IP model describe the function that occur in each layer. The reference model is a type model that provides consistency with all types of networks, protocols, and services by describing what has to be done at the particular layer. The example of this is OSI model. TCP model is like for what I've understand, OSI is divided version of a TCP model. For example, because of the application layer and the TCP model was divided into three an OSI model, which is application, presentation, and session. And all of it composed of TCP/IP protocol suite that belongs to the application layer. Next is the transport. Transport is nothing changed on the OSI model. And the internet was interchanged by network to the OSI model, and the network access from TCP/IP model was divided into two, which is data link and physical layer. And next, the OSI reference model. The application layer contains protocols used for process-to-process communication like HTTP, where the user interacts. And presentation, the presentation layer provides a common representation of data transferred between application layers services like GIFs, pictures, videos, like that. The sessions layer provides services to the presentation layer to organize its dialogue and to manage data exchange. And transport's like it's like the on the TCP/IP, which it it creates the segment from the data, create the data to become a segment, and the network is the pack network that provides services exchange individual pieces of data over a network identified and devices, which the data becomes a packet. Then next, the data link. Data link is protocols describe methods for exchanging data frames between devices over common media. And physical protocols describe mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connections for it. TCP, TCP/IP model applications represent data to the users, transport supports communication, and internet determine the best path through the network, and network controls the hardware, device, and media to make up the network. Okay. Message segmentation. Okay, let's look for this. Okay, multiplexing. Okay, on the what do you call it segmentation, the message is divided, and the divided message was sent individually to the server, and and on the multiplexing, the message of two computers was was divided both, and they send each divided message simultaneously. Then the next is communicating with the pieces labeled for each direction. Okay. Protocol data units. Protocol data units is based on this encapsulation and this figure. The data is the general term for the PD used for the application layer. It's the data from application layer, and if it becomes encapsulated on the TCP or on the transport layer, it becomes a segment. It will the data will be divided, and it the data will be having a transport header for the transport, which identify the data as a segment. Then the segment will be encapsulated as a packet on not on on um IP or internet or network protocol. It will provided by a network header, transport header, and data. It means that it's a packet. It's encapsulated and become a packet. And the packet will be encapsulated to the data link. The packet will become frame with a network header, transport header, and a frame trailer, which verifies if there an error and become a bit when it's flowed through the media. Encapsulation sample. It's like the video before, so I wouldn't play it. And next, the encapsulation. The encapsulation is how does the how does the destination receive it and de-encapsulate the message. Next. Okay, okay. Data link addresses. Oh, Okay, let's proceed. Device and simulator network portion and host portion. Okay, and this is the network portion. And network layer address, leftmost part is the network portion here, and this is the host portion. And the source IP address is here that we're going to send. We're going to send here message here. Source MAC address is the here. No, here, and the destination is role of the network layer address when sender. When sender of the packet is on a different network from the receiver, the source and destination IP address will represent hosts on different networks. And that's all for our chapter 3. I hope you like the video and understand what I've said, and I hope you learned something from me.